assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So in this solution, we will have a chemical reaction like this, where uh, the silver ion will react with the aqueous ammonia um, to form an equilibrium with diamine silver complex. So these are the species we will have in the equilibrium of this solution. So to find out or to calculate the equilibrium concentration of this species, first we have to form our ice table, and before forming our ice table we need to know um, all of the species initial concentration. So for the silver ion, we are given that it's a 0.38 molar solution. We need to calculate the molarity of this one, and this one, our the complex is, the initial concentration is 0. So for the ammonia, we just have to divide the number of moles of ammonia, which is 0.32, and we are dissolving the ammonia in a silver nitrate solution of 0.47 liter. So ultimately, if we do the calculation, we will find 0.68 molar NH3. So the NH3, the ammonia concentration is 0.68 molar. So now let's form our ice table. So this is our initial concentrations, and then if we let the change as x, so x mole is decreasing from the first one, or the silver ion, and since from the main equation or the balanced equation, we can see that 2 molar ammonia reacts with 1 molar silver ion. That means we will lose 2 mole of ammonia from here, and we will have x mole of diamine silver complex formed. And then in the equilibrium, we will have 0.38 minus x, 0.68 minus 2x, and then here x. So now let's arrange them in the form of the equilibrium constant. So the equilibrium constant for this reaction will be, on the top we will have our product or the complex, and in the denominator we'll have our silver ion and ammonia concentration, and since we have a coefficient of 2 in case of ammonia, we'll have to square it up. And then if we just put the concentration values, or the the equilibrium concentration values, we have x as the concentration of complex, and for silver we have 0.38 minus x, and the ammonia will have 0.68 minus 2x. We have a square here. So if we, and we have a value of the equilibrium constant, which is 1.7 times 10 to the power 7 is equal to this one, this. And if we just solve the equation, we will have an equation like this. So square minus 2.5432 times 10 to the power 7x plus 0.2987104 times 10 to the power 7 is equal to 0. So if we solve this equation with a graphing calculator or any kind of online calculator, you will see that the x has, there is three possible values for x: 0.38, 0.3396, and 0.3404. So among these three values, this one is not possible, because if this is the value of x, then you will see that we will have all the silver ion consumed in the equilibrium concentration. And again, this one is also not possible, because if we multiply it by 2, then we'll see that uh, it will go beyond our ammonia initial concentration. So this one is not also possible. So the only possible value of x here is 0.3396. So using this value, we can now calculate the equilibrium concentration of all the species here. So our complex will have a, since its equilibrium concentration is x, that means it will have 0.3396 mole concentration in the equilibrium. And then our ammonia will have concentration of 0.68 minus 2x, and we'll see that it will be 0.0008 molar. And then finally our Az plus will have a concentration of 0.38 minus x is equal to 0.0404 m.